Hi, welcome to another meeting of iChime. In this meeting, DB2 for I performance expert Kent Milligan went step by step with us, and he demonstrated how to first diagnose a problem, how to identify the different parameters that might be wrong, and more importantly, how to make adjustments to your system to help fix what's going on in your system. How to get a real round view of what's happening on your system. And it's not just for performance problems, it's just for everyday use to nip things in the bud and find out in advance for preventive maintenance. This is also a very good thing. Some of the most seasoned SQL people that I know who attended the meeting told me that they took away something of value. So it was really a great meeting to watch. I encourage you to watch the whole thing. Really worth your time. And my highest praise and thank you to Kent for your time once again. Everybody had a great experience, and I hope you do too. Take care, everybody. Bye now. Enjoy the meeting. Kent Milligan is a senior DB2 for I consultant in IBM Technology Expert Labs. Kent has over 25 years of experience as a DB2 for IBMi consultant and developer working out of the IBM Rochester lab. Prior to rejoining the DB2 for I Expert Labs in 2020, Kent spent 5 years working on healthcare solutions powered by IBM Watson Technologies. Kent is a highly sought after speaker and author on DB2 for I and SQL topics, including his DB2 for I blog. And before we go any further, I'm just going to show you that. And if you're not familiar with this, you are now. DB2 for I. This is an incredible resource that Kent keeps very current. He blogs. And Kent, do you want to just talk about this briefly? What inspires you for different things, and different things that you've already written about in the past?
Yeah, I'd say the main thing that really kind of drove my interest in doing that is that the development team in Rochester, right? Quite a change over the last couple years. That not only do you get new DB2 capabilities when a new release comes out, but they're often part of a database group PTF. And I really kind of started it to just have the ability to highlight kind of new things that come out that might be slip under the radar because they're regularly delivering new enhancements and new services and tools.
I tell you, I've been on this blog site, and the articles just don't seem to end, and they're very informative, and it's not fluff. It's really good information, very meaningful things you can start using immediately. Very, very well written stuff. So thank you for continuing to do this blog, Kent. I think,
Yeah,
and I'm
well,
sure the community is very, very, very grateful for it. So thank you for that.
I'm glad you found it useful.
Absolutely, 100%. Absolutely. The other thing I want to talk about is, of course, the IBM Expert Technology Labs. And this is a service that IBM offers, but I would like Kent to really talk about this. It's a great service that IBM offers, and I'll stop talking. And Kent, why don't you just talk about that a little bit?
Yeah, so expert labs kind of evolved, or is the current organization maybe people that have been around the platform a while remember IBM Lab Services, but it's really just a group that's focused on helping clients, adopt and leverage and integrate the latest IBMi and power technologies into their environments, right? So as new stuff comes out, people often need help getting up to speed on that and help implementing it to have the biggest impact on their business and IT solutions. So that's what our group's available for customers to hire and assist with their implementations.
And you've seen customers of all sizes work with IBM on this.
Yeah, yep, yep. Just like the IBMi client space is both small, medium, and large customers. And I know that with the DB2 and SQL team that I'm part of, we deal with kind of the range of clients.
And it's a great way to really get questions answered if you're stuck with something, or to even or for planning a new system or an application, I suppose.
Right. Yep. And kind of offer a variety of services. Some are kind of very focused on one particular project or technology area, and then they've evolved more recently into offerings like IBM Expertise Connect that, it's what you're saying, you kind of are assigned a technology expert that as questions come along, you have the ability to access them and have them maybe review an implementation proposal, or like you said, just answer a specific question when you're implementing a new technology.
Excellent. Well, anyway, yes. So it's a great service. I'm glad IBM offers it, and I recommend anybody avail themselves to the service at any point when you need it, because they will get you through anything you need to get through in that regard. With that, I just want to give you, here is also just one more thing. This is the IBM website, a screenshot that just talks about it a little bit more if you want more. And this is the link on the bottom. If you want to take a screenshot of that, you can see it. And that'll get you started with IBM Technology Expert Labs. So good deal. I'm going to stop sharing. There we go. Excellent. And Kent, I am going to turn this over to you. The name of today's meeting is Peak Your IBMi Performance Using SQL Plan Cache. I can tell you that this is a topic that needs to be talked about. I know what you're going to show us is very valuable, because the plan caches can, when you use it properly, can really make a huge difference in how you develop code, I suppose, or develop SQL queries.
Right. Yep.
Okay.
Yep.
So I'm going to turn this over to you, Kent. I can tell you that you have our undivided attention, and I will monitor the chat. I'll monitor the chat if anybody has any questions. And Kent, the stage is yours. Thank you very much.
All right. Thanks, Charlie. Hello, everyone. So yeah, as Charlie mentioned, I kind of want to talk about how you can leverage the plan cache to be more productive and get more high-performing queries on your system. So what I thought I'd do is I'd start off kind of talking about how the plan cache is used as part of the normal Db2 query execution. And if you're not aware, when you run a query in your application, there's actually 3 steps it has to go through. And those 3 steps are optimize, open, and run, right? Run is actually executing the query and returning the results back to the application. Optimize is where you might expect the Db2 query optimizer gets involved, right? And that's really the benefit of using SQL, is that you as the developer don't have to worry so much about the performance implementation. That's the optimizer's job. And I like to think of the optimizer a lot like a GPS, right? That if we ignore self-driving cars and that coming online, that a GPS looks at your starting point and your end point, and it looks at all the possible routes and the different speeds of those roads to figure what's the fastest way to get you to your endpoint. And if you think about a query, the destination is really your query, right? That's defining the results that you want. And the starting point are the tables that contain your data that you want to contribute to that final result set. And so really the optimizer's job then is it knows those tables reside on disk, and it's going to look at the fastest ways to retrieve that data from disk. If you're doing aggregation in your query, what are the fastest ways to aggregate or sort the data, and then come up with a plan, which is like the GPS directions on the fastest way to run your query. And the plan cache, the purpose it solves is that if you're running, your application is running the same query over and over again, those directions, the implementation on how to run your query probably isn't going to change every time you run the query. So that allows us to come up with those fastest implementation steps and directions once and store it in the plan cache and reuse it. Right? And think about maybe back several years ago when direction software like MapQuest came out, right? What you would probably do in that case is you'd print off the directions to maybe your client or your relative's house, and then you would save those away and reuse it the next time you went there instead of printing out the MapQuest or GPS directions every time. And that's really what the plan cache allows us to do, is figure out the fastest route once, and assuming nothing's changed is with your database, then just reuse that over and over again. And now that optimized step of the 3 steps needed to run your query is going to be faster because we're not coming up with the directions on how do you run your query on every query execution.
And that makes a huge difference in performance, obviously.
Right. Yep. It's kind of like using the name of it is a cache, right? That if you have the same answer, the same approach, let's store it away and reuse it instead of coming up with the same answer, the same approach every time you run your query. And so I'll share my screen briefly here to kind of give you a diagram of how the plan cache works. Let me hit share here. All right. Are you seeing my plan cache diagram screen?
We do see the screen, Kent, yes.
Okay. All right. So on the left-hand side is that centralized repository called the query plan cache. Okay. And that's when the optimizer's done figuring out the fastest way to run your query. That's when we're going to store that and reuse that. And what the ACS SQL Performance Center is doing is really giving you a graphical interface to navigate and look at, excuse me here, wrong button.
Right now we're seeing a dark screen.
Yeah, yep. Oh, I hit advance. There we go. How about that?
Okay, we're back. We see it.
All right. Okay, so we see now the centralized repository on the left. And as I'm running different queries in my program, how we persist and cache those plans in the plan cache. And so the great thing about the ACS SQL Performance Center tooling giving you access to look at how the query was implemented and how many times it's been run is that it's part of the normal query execution, meaning there's no overhead to using this tool because it's just used normally as part of that optimized step of the 3 steps needed to run your query. Prior to the plan cache, we had some query performance tools, but they were an add-on to the query execution process, meaning they could add potentially on a production system a lot of overhead if you wanted to collect SQL performance data and analyze it. Now, because we've learned this is just part of the normal query execution, you don't have to worry about slowing down your production system when you want to look at SQL performance data.
So I have a question for you, Kent. So is this plan, first of all, the plan cache is on everybody's machine. Is that a true statement?
Yep.
And it's always on by default?
Always on by default.
And is the plan cache involved in all SQL statements, all queries, or is it based on the complexity of the query? How does that work? When does the plan cache get involved?
Yep, so that's a good question. And that's, I think initially some of the tools even said SQL plan cache when it first came out. And we've evolved more towards plan cache or query plan cache because it only is used for SQL statements that run a query, right? So obviously a select statement is running a query. An update or delete is running a query because you're identifying which rows you want updated or deleted. So there's filtering or selection of rows involved. However, if you're just running a simple insert statement that inserts a row and you're not invoking any SQL functions to convert any of the data, the plan cache will not be used at all as part of that insert statement because there's no query that's being run as part of that SQL execution.
That's a direct insert and there's no planning necessary.
Right. Yep, because in that case, Db2 says, oh, we know where the next row goes in that table. We don't need to come up with a plan of how to find that row that we want to insert like we do when you're running a query or deleting a row from a table. And then obviously you have SQL statements like, create table, commit, rollback, create index. They're not doing any query processing. So the plan cache isn't going to be involved with those as well.
So this plan cache can get pretty large if you're running extensive SQL in your system, I would imagine. Is there a concern about that?
Definitely a concern, but the good news is, because we've had this design point through the years with DB2 for I and its predecessors of no traditional DBA required, DB2 kind of manages and allocates the storage by default for the plan cache. And really, the variety of SQL statements being run will determine how big your plan cache size is, right? So if you have a system, maybe you're running an ERP application that's running SQL, well, then on that system, then it's really the same SQL statements probably being run over and over again by the end users. Probably on that system, the plan cache is going to be relatively small.
Right.
But if you had a system that's maybe dedicated to reporting and analytics, where you're going to have a wide variety of different queries, then potentially in that case, that plan cache would be bigger because we're having to support a bigger variety of different queries on the system.
Does it matter, Ken, for the plan cache, does it matter how the SQL, where it's being called from or how it's being called, or if it's even a dynamic statement? Does that have any impact on this?
Yeah, so no, that's a good point, Charlie. And that was the other thing I wanted to highlight with this picture before we get into some hands-on.
Okay.
Is to kind of demonstrate how this changed because the plan cache is only used by the newer SQL query engine, right? And that was first introduced in V5R2. So we're going back quite a few years. And since V7R1, it's supported all SQL syntax on the system. But before the query plan cache, the plans with the classic query engine were stored in the program object if I'm static SQL, where I'm embedding an SQL query within an RPG or COBOL program. And if I was dynamic SQL, whether that's from an RPG program or maybe a Java program submitting JDBC requests to the server, you can see in that case, the plan, once the optimizer built it, was actually stored in memory for the job. And then that was problematic because when your job or your database connection went away, guess what happens to the plan? The plan would disappear. And now when the JDBC application connected again and needs to run the same SQL statement, we'd have to take time on that optimize step to replace the plan that got deleted when the job ended on the system.
When the job ended.
Right.
But the plans do remain in the plan cache. Actually, I'm asking the question. The plans do remain once a regular job is ended, or they go away.
That's what the query plan cache had the ability to provide, is that because they're no longer tied to a job, the plan is stored in the plan cache.
Right.
Now, when this job goes away, the plan can be persisted in the plan cache. And now, when the JDBC application reconnects, we find it in the plan cache. And now that next execution is going to be faster. And
Makes
that's
perfect
one of
sense.
the reasons that in the past, maybe you've seen these extended dynamic SQL packages. It's a connection property on some of the IBM ACS ODBC and JDBC middleware, where we had to invent kind of that flavor of SQL so you could do JDBC and have the plan permanently stored in a permanent object known as an SQL package object. And then when your JDBC connection or ODBC connection went away, that plan would persist. And so this is really showing that now with the query plan cache, kind of the need for these extended dynamic packages is less, because we've learned now that the plans can persist even though the jobs running the SQL might disappear or be ended on the server.
There is a message in the chat, and it's a common question, and that is that how long do the plans remain intact? There's always that concern that I know that about IPLs and the impact that they have on the plan cache and other things as well. But what impact do they have in this context? Does an IPL have, I should say?
Yes, so that's a very good point. This plan cache, as you might imply from the name, cache is a temporary object. So that means when the system is IPL, this would get completely wiped out. And then after the IPL, Db2 will allocate space for it. And as you start running queries and SQL requests, we start calling the optimizer to build the plan and repopulating that plan cache.
So this is just further proof. I mean, you hear these stories. People say, "Oh, we IPL every weekend for whatever reason," which is the older thinking and maybe the older strategy, but not
Right.
appropriate anymore. Oh, and the machine tends to run, or it does run a lot slower on Monday than it does on Friday.
Right. Yep. I kind of call that the Monday morning blues, that if you're still following that old IPL strategy that, IBM's addressed the issues with temporary address space and things, that 35 years ago, you might have had to IPL your AS400 weekly. Now, if you're still employing that strategy, and expert labs, we find clients all the time that are doing this weekly. Now, if you're using SQL applications, there's going to be a slowdown for those first set of users on Monday morning after the IPL.
You've even written a blog about this very point.
Yeah, I think it is, because it's a common issue. Now, the good news is probably by the time that people notice the problem, it's solved, right? Because by the time they call the help desk and people have been running the applications, probably a lot of the more commonly run queries, their plans have been populated into the plan cache, and now the problem has been solved with that optimized step being a little slower.
Automatically.
Yep.
Yeah. All right. Well, I know you had planned, or you do plan, I should say, to do some live demos for us. So,
Yep. So let me kind of drop this chart here, and hopefully that was a good visualization. I guess the other thing I'll point out, that before we do that, the other value the query plan cache has is, notice this plan 7. It's shared or run by two different SQL interfaces. An SQL program, let's say it's an RPG program running the select, and let's say I have a JDBC application running the same select statement. Notice the plan cache allows one copy of that plan to be shared. in the past, with the classic query engine, we would have had to build one copy of the plan for that RPG program, and we would have had to build another copy of the plan for that JDBC application, and kind of wasting system resources because we didn't have the ability to share a plan like the plan cache now provides.
So most customers today, based on just the OS that they're running, they're using all SQE. Nobody, I mean, is anybody even really using the classic query engine anymore, the CQE?
They shouldn't be for the most part. There is a proprietary, I can't remember the number of Qs in it, the QQQ query API that we have a couple of tool vendors in the past that have written to. That still does require the use of the classic query engine. So it's possible, but it's pretty much limited to the customers that are using these third-party tools that write to the old API.
For everyday pedestrian mainstream development, though, we're living in the SQE at this point.
Yeah. If you're just running SQL, and I guess the other thing I'll highlight here, you should really call it a query plan cache. That since I think 7.3, Open Query File and Query 400 also use the SQL query engine, and their plans would show up in this plan cache as well.
Right. So at that point, just by going to the newer version, you were getting a bump in performance just by mere virtue of going to the newer OS.
Yep, you should in general. Yep.
Great.
I mean, optimizers are not perfect, so I'm not going to sit here and say the SQL query engine builds plans that are always faster than what the classic query engine does, but the majority of the time that is true. Yep.
Great.
Yep. All right, so let me end the slideshow here. And then we'll talk about the tooling. So ACS is your entry point, and SQL Performance Center is how you launch and get access to the plan cache related tooling. I think I'm using 11910 that was released in December for my ACS version, but it's been in ACS for a while. But I think 1197, some of the names and links might have changed slightly. But if you want to see the contents, all the different query plans in the plan cache, that's where this plan cache statements link comes into play. And so when you bring that up, you'll see that the list is initially empty, right? Potentially the plan cache could have thousands of query plans in it. So the thought process is why would we waste time retrieving, hundreds of query plans when it's more of specific query that you want to look at? So we have a number of filters to help you kind of focus your analysis. So the first one is the minimum runtime, right? So if the query is running less than 1 second, you probably have bigger fish you want to fry, right? In terms of improving performance, you might want to start at queries that are running greater than 5 seconds, for example. So it gives you the ability to focus on the longer running queries. Statements that are run after a particular point in time, that might be useful if, maybe you're on the application development team and your system administrator contacts your team and says, starting at 11 a.m. today, the system really started running slower. Well, if you want to see kind of what query plans have been used since 11 o'clock today, you could focus your analysis that way. Oops, I guess it reset there. And now I can see the query plans that were run after a particular point in time. And now I'll do Control Plus, but you can kind of see, you can sort based on the last time run. So you can maybe see if it started or was in that window where the system started being slower. Obviously, sorting on average processing time might be a good one to focus on, right? We have a couple here at the top, that are running multiple seconds that often are culprits because they're running so long of why the system is running slow. So that's how clients tend to use that filter.
I have a question in the chat.
Yeah, go ahead.
The question is: this somewhat resembles Index Advisor. How different is this from Index Advisor?
Yeah, that's good perspective. So Index Advisor, every time a query is run or a query plan is built, if the optimizer recommends that an index might help improve performance, we would write that data to a table in QSys2, and then there's a timestamp column similar to this last time run column. In that case, it would be last time the query was advised, or the index was advised by the optimizer. And so the index advisor is basically recording feedback of when we built this plan. Was there an index advised as part of that plan creation? If there wasn't, right, you had all the right indexes in place to run the query, there wouldn't be any index advice generated. But if the optimizer thought that there might be some possibilities to improve the performance of your query, then the index advice would get updated.
Perfect. Thank you for that.
Yep. Yep. All right. So moving down the filters here, there's a couple of these that I kind of would classify as, good to use, being proactive. So often it's useful to understand which query plans are used most frequently on your system, because then based on how often they're run, right, even if you can make a little improvement, you're going to have a big impact overall on your system. And I guess I didn't highlight this, but notice that the text comes back initially really small, and I'm doing Control Plus so that it's hopefully more readable for you on your end. And it's definitely more readable for me as my eyes get older to be able to look at all the details here. When you do the total times run, it does not sort that in that order by default. So you would click on the total times run column, and now you can see that we have a couple queries here that are an order of magnitude more than others in terms of how often they're run on the system, right? And so maybe you start at the top because it's executed an order of magnitude more than all the other ones. Or maybe you might look at the ones with a slightly longer average execution time to see what can be done on these. Now, a couple of things to be aware of. We talked about the plan cache being created at IPL. This record here that it's been executed over 2 million times does not necessarily mean it's been executed 2 million times since the last IPL. All you know is the last time that this query plan was used, you can see, was actually back in 2025. So that plan was created and then last used, or we don't know when it was created, but we know it was last used on November 10th of 2025. But we don't know if that query plan was created previously and maybe run 500,000 times, and then because it wasn't run very frequently, it was removed from the plan cache. So you do have to be a little bit careful when you're looking at the number of times run or the total accumulated time to realize you don't know if that dates back to the IPL. It could, or it could just be that since that plan was last used, right? Maybe it was right before that plan was created, and we started incrementing these usage counts when the queries were done running.
That's a good
And I
point.
do think they're considering in the future maybe a column that would say when that entry was added to the plan cache, but that information is not there today.
Is this a tool that you would normally just go into just as a DBE, for example? Is this a tool that you would typically just go into just to monitor what's going on, or is this more for troubleshooting, or both of those scenarios, or more scenarios even?
Definitely could be used to be proactive or react, like you were talking about the earlier filter, right? You know, the system administrator said since noon today, the system's really slow. Can you see if query activity might be called? But these top 25 most frequently run statements, and then the filter to look at the top 25 queries with the largest accumulated runtime. Those, what I recommend when I'm working with database engineers, are things that I'd be doing at least once a week to try to stay ahead of my query performance problems and generate that list of those 25 queries or 10 queries, whatever you have time to do, and then start going through here and use Visual Explain to determine, okay, I see that it's executed a fair amount, 253 times. It's not just a query that's run once, right? Here we can see back in May, there's a query that's run once that's longer running. Well, I'm going to spend my time on queries that are more recently run. And then I'm not going to get into super details here on how you use Visual Explain, but then you could use Visual Explain to determine, is there anything that can be done to make this query run faster? And, we can see in this case that it's using some IBMi service, and traditional, database methods of adding an index really aren't going to be useful in those situations.
But this is another very valid tool in your toolbox.
Yeah. And the interesting part here, and this is not uncommon, I'm using one of the common systems here, but I often find this on client systems, is that IBM, right, has done a really good job of creating these IBMi services like this one that can generate a spreadsheet. Let's look at what this one's doing here. This looks like maybe it's looking at the release level of the operating system or environment system information. That's a lot of clients forget about the performance aspect, right? They see these IBMi services and think, well, they're from IBM, their performance must be really efficient, but they don't understand that a lot of these services are calling programs, not reading rows from a table, which can add a lot of overhead on the system. And we can see in this case, right, that the top 3 queries are not doing anything related to application queries. They're looking at getting feedback from the operating system, and that's what's taking the most cycles on your system. So a lot of times I tell clients, do you realize you're checking their number of remote connections like 2,000 times a day? And because that query is showing up here at the top.
We had Dawn May on a few months ago, another performance expert, and she echoed your sentiment right there. She was, the IBM about the IBM services, as great as they are, they do, they are running code underneath too.
Right. Yeah. So you just need to be aware and okay, maybe I don't need to know the exact number of remote connections every 5 minutes. Maybe let's scale that back to 15 minutes. But I had one casino where I did this. This is something I usually start with, the top 25 most time consuming queries on their system. And of the 25 in their case, 20 of them were all using IBMi services. There were only 5 of their top 25 most time consuming queries that were actually application queries. And that's probably not where they wanted their system resources devoted to. Oh. All right, so let's pop down here. One that can cause a little bit of confusion here, and you can see we can, if you have that problem user on your system, you can specify a specific user profile and look at the queries they're running. The other thing this shows, so that's my user profile. Let's look at the queries that I've run on the system and kind of prove that, I've been running some things on the system. Well, notice I could say a lot of times, maybe I want to look at a specific user's top 5 most time consuming queries to get him to stop doing that on the system. Well, you have to be a little careful because that filters, when you're combining multiple filters, doesn't do exactly what you're saying. It ands those 2 criteria together, right? Because I just proved here, right, that there are queries that I've run on the system. Yes, when I asked for my top 5, I got an empty list. And what it does is it takes my query plans that we saw on this tab and then says, okay, I have a list of all the queries that Kent's run. Now with this filter, I'm going to generate a list of the top 5 queries with the most accumulated runtime, and I'm going to see if there's an intersection between those 2. And in this case, even though I have run queries, this is telling me none of the queries that I'm running have made it into the top 5 overall on the system. So if you start using multiple filters and you're not getting any hits, then I'd really recommend that you kind of back off and do one filter at a time. Okay. The other one I want to point out here is we have an object filter. And this object filter is applied at the query plan level after the optimizer has figured out how he's going to implement your query. It's not applied to the statement text. So I have an orders table in this library here that I'm going to add as my filter and say, now I want to see all the queries that reference that table. And it generates this list. And now notice, if I look at the statement text, obviously this first one is referencing the orders table together or directly, but notice the second one. There's no reference to the orders table there. High priority is actually an SQL view created over the orders table that retrieves those orders with a priority level of 1. But because the object filter is applied to the plan implementation, where the optimizer figured out high priority is just an SQL view that points to the orders table, I now see that in the list of queries being executed. And that's the biggest difference between the object filter, it's applied to the query plan implementation, versus the text filter is only applied to the query text that was run. So if I now put orders in the text filter, we no longer see the other queries that were accessing the orders table via an SQL view.
Interesting. What about, does this help me identify if I have like a temporary index, for example? Is this going to help me identify those where, and then I can then, maybe create a permanent index at that point?
Yeah. So that's kind of a real clever use that an SQL statement by default can never reference an index, whether it's permanent or temporary in the statement itself. And so because it's the optimizer's job to say, maybe I'm going to use an index to speed up your query, that's a real clever way to use this object filter we were talking about. And so if any of you have used or looked at temporary indexes on that Db2 creates, all of them start with the prefix MTI left paren. So if I make that my object filter, and now I hit show, this is going to find all the query plans that are dependent on a temporary index on the system. And those are really a big deal because, Charlie brought up that earlier, some people still IPL weekly. Well, not only is the plan going to disappear, but if their queries were dependent on a temporary index, all those temporary indexes are going to disappear. And that's going to make their system extra slow at IPL. And this is a pretty common issue that I've worked with a number of clients over the last couple months, that they never look and replace their temporary indexes with permanent indexes. And then when they IPL their systems or they stand up an independent ASP, performance is horrible because those temporary indexes, it might take 5, 20, 30 executions before DB2 decides to create them again. So by using this object filter, now I can see which queries are run most frequently that have temporary indexes, or maybe that have the longest average execution time. Maybe those are the queries I want to start with creating a permanent index for. And so now if I go to the query plan using Visual Explain, this is a pretty complicated query. Let's see if we can find the temporary index here quickly. And yep, we do see the temporary index being created there. This is just one way to get temporary index information, but now I can see over this all object users table, it's creating a temporary index over this column. So based on the frequency of that query execution, that's probably a temporary index that I'd want to replace with a permanent index.
And performance really is an art form, isn't it?
Yep. It's definitely not black and white necessarily, but there's, some things that you can look for. Temporary indexes are an easy one to say, hey, I want consistent query performance. It's great that DB2's auto-tuned my query, but I don't want to rely on an index that might disappear at any point in time and make my query a little slower.
So here's another question for you. So somebody calls in the help desk and saying, I'm having a problem, whatever the most likely performance, I would think, and then you bring up this screen right here. What's the first thing you would look at?
Probably what I was saying earlier, the largest accumulated runtime is where I would start, because that's whether it's one execution of that query or 10 executions of that query, those are the things that are probably taking the most time in the application and causing slowdowns that end users might complain about. So then you would, look at average processing time. You do get some job information in the plan cache. So there is a column that has the job that was responsible for creating the plan initially. and the user that was responsible, the user profile that was active when that query was run, when that plan cache entry got populated. And then the other thing that you get when you right click, the live plan cache will show you the job history or the user history of who has used that plan since it's been in the plan cache. And now as a help desk person, right, you could verify that is that the job the application's using or the user profile they're using, and determine whether that's the query you want to spend time trying to analyze and tune in some way.
Would you have any real reason to need to compare two different plans? Can you discern any value from that?
So that's kind of an interesting thing. So if I sort here, I haven't really talked about this Curo hash column.
I don't mean to jump ahead of you. I'm just questioning.
Yeah, nope. That was kind of the train where the track I was going down.
Okay.
I will point out that, based on my earlier description, you'd think when you look at the plan cache, if I look at one query, it would have one entry in the plan cache, and we can see, even just looking at this first set of query text, it appears that that's the same query and it shows up multiple times. And the way that you can validate, I mean, obviously you could look at the query text and compare this column, Curo hash, when it's the same, that tells you the query request was the same. Because a hashing algorithm in general in the IT world, it is guaranteed to produce the same output value, the same hash value when the input stream, your query request, is the same. And so that's why when I'm looking at the plan cache, I always put the Curo hash column right before it, because then, even though I'm only seeing the first 30, 40 characters, by looking at that hash value, I know it's the same query text.
Identical.
Yep, identical. And so now the next logical question is, why might that query show up multiple times in the plan cache? And that's because maybe that query is run at different times a day, where the memory pool it's running in has a different size, right? You could have cube performance adjust system value enable the operating system, right, to move memory from one pool to the other. And so when there's differences in the key settings that affect optimization, like the size of your memory pool, we say, you know what? Well, if you're running this query during the day, maybe when the memory pool is smaller, we'll create one plan that performs best with the smaller memory pool. And then we'll create a second plan that the query is run at night in a bigger memory pool. And then instead of replacing that plan every time you run it with different settings, we'll just jump or toggle back and forth between those two plans. And by default, the system's designed to be able to store up to 3 plans for a single query. And we can see that in this particular case, here's the same query because the Curo hash is the same, where it has 3 different query plans. Maybe in addition to memory pool size being different, maybe it's being run with parallel processing turned on. So again, instead of having to do that optimize step over and over again, we're able to jump to the plan for that one query that matches the settings, the environment that it's running in.
The question is starting to come in, Kent.
All right.
Here's one that somebody posted, but we had a similar thing at one of our clients also. I'll just read it to you. I have one update that is taking about 1,000 seconds. The table is updating is pretty simple, small in number of fields and rows, etc. How can I tell what's going on with an update?
Okay.
And I can tell you that we had a similar situation with an insert, similar problem, I think.
hmm Yeah, I mean that's where you get into kind of the art of using visual explain. Um, so once you identify the query here, that's when, and I'm just looking at these. A lot of these are all IBMi services that we're talking about, so they're not going to be very useful examples. Because they're all calling programs or functions like we talked about earlier. So you can get at this information in the live plan cache, but have kind of captured a snapshot. So what a snapshot is the plan cache, right? By its name is a live breathing object. So potentially, if I find this query is what I want to analyze, and then I go get a cup of coffee, when I come back, this could disappear out of the plan cache if it's not run very frequently. So what a snapshot allows you to do, and you can create this programmatically or through the GUI, is basically copy the contents of the plan cache into a static object called a snapshot, and that's just a table. So you can give it a name, and give it a library, and then you can see, do I want all the plans or filtering of the plans using all the filters we kind of walked through. So I've kind of done that previously. And if I look at this snapshot that I took previously and do show statements, you can see a very similar interface. And kind of Charlie's point about the update statement here. Oh, I forgot that I did all of them. So I probably wanted to specify a filter here. So let's look at ones that were referencing the orders table that I talked about earlier, just so we can see something that's more referencing a database table. Right, so here we see kind of in visual explain, and these row counts that go on the error labels, they're showing you where the most work is being done. And like the slow running update statement, that's where you might want to look at, or you could say on the arrow labels, or excuse me, the icon, there's an advisor, this little pencil. And if I say index advised, that would be the type of thing that I'd first look at in Visual Explain to say, first, is DB2 advising any indexes? And if he isn't, then I would look at these row counts to try to see where the most work's being done to get an understanding of what action's being taken. So Visual Explain is what you really have to, when you find a slow running statement, you have to get into the details of that. And, we have a whole, 3.5-day workshop where we, help clients become more proficient using Visual Explain. But that's where you'd want to go into.
Excellent. Thank you for that.
Yep.
Some more questions for you, please.
All right.
All right. The next one is using in the PDI, in the Performance Data Investigator, we can see the signature of the plan cache, including plans built, plans removed, and plans pruned. Is it bad if there are a lot of plans being pruned? For example, constant pruning going on and the number of plans pruned is just as large as the plans built.
I guess I have to start with the answer. It depends. And the plan cache properties do give you some insight to those same metrics that Performance Data Investigator. So if I go to the plan cache tab, I can see potentially the ones that are related to those statistics. So plans removed are because the plan's no longer valid, right? Maybe I was running the query without an index. I created the index that was being advised. Well, there's no reason to keep that plan around. It's not usable, so we're going to remove it. Plans pruned, if that counter is going up pretty frequently, that would indicate that maybe you have a lot of different queries being run, and we're having to make room for new query plans. And DB2 is doing a balancing act, right? Because we know that the temporary storage is limited. We can't allow that plan cache to grow infinitely in size and exhaust your temporary storage. So he is using this plan cache hit ratio to determine, should I increase the size of the plan cache? You can see on the common system, I'm just under 6 gigabytes. Or should I keep the plan cache size the same? And what the hit ratio says is when you run a query and you have to do that first optimize step, how often were we able to use a plan from the plan cache instead of building a new plan and inserting it into the plan cache? You can see the target default, the goal is 90%. On this common system, it's only 13%. So that's pretty low. However, think about how people use this common system, right? They're using it to do demonstrations or proof of concepts, right? Nobody's on here running an ERP package that's running the same SQL statements over and over again.
Valid point.
So,
this is not representative of a typical production system.
Right. But that's what we're looking at, and that's what's factoring into plans prune to say, well, because 13% of the time in this case, I'm not finding a plan, I'm probably going to add plans and not prune plans because that hit ratio is so low. And we saw evidence of that, right? If we go back to one of these, right? Weren't we looking at a query plan? Here's one that's last been used on September 7th, right? So because this system isn't having a lot of SQL being run, the plans are more likely to stay persistent. But if I'm seeing plans prune very high, that tells me you're probably on a system where the number of different SQL being run is pretty frequent. So maybe the plan cache hit ratio is pretty good. So we're not going to increase the size of their plan cache. So when a new query comes in, we have to remove a query plan to make room for the new query plan. And that's where I was talking about earlier, that the plan cache is a live breathing object that can be hit or miss. And that's why plan cache snapshots are so important to take regularly on your system.
Well, I'm going to stay on that line of snapshots because another question came in. I think it's interesting. I'm going to just add a little to the question first. The question is, if you identified something that could be improved and then made the improvement, be it an application change or even a PTF, for example, here's the question. Have you ever used snapshots to prove the regression after a PTF or application change? And what do you actually compare? How do you know that the change was for the better?
Right. So you could do it via the live plan cache, right? But then you'd have to copy and paste or store this in a spreadsheet. Kind of, maybe I capture this statement that I see the average execution time is 9.61 seconds. And then after I apply the PTFs or the new version of my applications, I could go find it. But if you have created snapshots, let me find the Performance Center window here again. What you can do is there is a compare feature built into ACS. So you would select the two snapshots that you want to compare. And it's going to do kind of a high level overview of how many different SQL statements are in the two snapshots, right? the number of users, jobs, so high level metrics. You're probably not going to get a lot of confirmation there. But then you can see on the next tab, there's a statement comparison where you can compare the individual statements that were being run, the individual queries that are being run. So we have some optional parameters, schema mask. That would be useful if you have a multi-tenant environment. Maybe you have an orders table in library A for your America customers, and you have the same orders table in library E for your European customers or end users, right? But they're running the same queries. The mask allows you to say, compare those even though they're really executing against different copies of the orders table. But in this case, we don't have multi-tenant. We can specify a minimum runtime, right? Am I only interested in comparing longer running queries versus shorter running queries? So we're going to let that default, but maybe I only want to see a comparison when there's a significant difference in the execution time of that query, right? Kind of to the point you're on, Charlie, that I want to see after I apply an application update or PTFs as things change significantly. So I'm going to set that at 10%, right? 1 or 2%, that's probably just noise. So I'm going to look for significant. And now when I hit compare, it's looking for the same query in each of those 2 snapshots that I've created. I'm going to focus on average time because total run time might be biased, right? Because maybe it was run 1,000 times in the old snapshot and 100 new. And look at here that, something did happen with average runtime. It got over 600% worse for this particular statement. And now I see the query, right, that was involved. If I look at the average runtime, you can see I was at 100th of a second, and now I'm at 700ths of a second, right? 6-7 times worse. And so now I do see that PTF or the application upgrade caused a problem. Well, we make it really easy to figure out what went wrong, because now if you hit Visual Explain, and it's putting it in another window, I get the Visual Explain side by side showing what happened. And by just quickly glancing here, we can see the orders table was using an index before. Now the orders table is not using an index, and you can see I have multiple indexes being advised. So maybe it was an application update and somebody didn't put these index definitions. They just created them dynamically on the system, and they got lost when they did the application upgrade. And now I kind of know, having the compare tool find that statement, put the Visual Explain side by side, I need to go figure out what happened to this index and this index that were being used before and providing better performance.
So let me expand on that very point. If let's say you're running development partition and a production partition, or even whatever, another system partition, doesn't matter. Can you import a snapshot into one ACS, as you're seeing right here, to compare?
Yep. So because the snapshot is just a DB2 table, right? So let's say that Common 7.5 is my development system, and I think, what is it? Common 1 is the other common partition.
I think so.
On Common 1, I would create that snapshot. I would save that snapshot, just a DB2 table, to a save file. I would restore that save file on Common 7.5, restore that DB2 table, and then from ACS, I can do import from the SQL Performance Center. I don't know what the descriptive name was, but let's say it was Common 1 snapshot. It doesn't have to be the same snapshot name as the other system. It's whatever I want that descriptive name to be. Then I'd point it at the library. where I restored that DB2 table object, and then I could hit OK, and now it's going to import it or register it. So now I can use all these great graphical tools to do the compare or show statements that we've done.
And what I described to you is a perfect scenario. One you're running before you want to commit it to production, you can test it out in development.
Right. Yep. That's a great scenario. And then the other one that not a lot of people are doing is kind of what you were talking about before the PTF update or the application update, is creating a snapshot before you make changes.
Similar idea.
Yep. Yep. Because then if something goes wrong, you have something to compare against versus it's slower and now you have nothing to compare against, and
Right.
now you're wandering around in the dark to find out what's slower. So if anything, I would challenge people that if you're not taking snapshots at least once a week on your production system, I would have a scheduled job that does that. So you always have that baseline. I have large clients, they do it every day, like at noon. And if you're not aware, there is a service. Obviously, you can do it from the GUI, but you don't want to log in every day or every Friday. It's called Dump Plan Cache, and you just give it the name of the output file. Call it Daily Snap. And you could use the run SQL command or the run SQL statement command, put that in a scheduled job. And now, once a day or once a week, proactively capture that snapshot. So when things don't go so well with performance, you have something to compare against.
So that's how you would dump it. So there's no way to read it in real time with some other service. That's the way to do it.
Yeah, no, I think you would want a permanent copy. There is an extract statements service, but again, because the plan cache is changing on the fly, I think you're better off getting that static copy that you can do the compare against if you need to in the future.
Some more questions for you, please.
Okay.
If one increases the plan cache size manually, is there any benefit in order to do so on a large enterprise system with lots of SQL activity at the expense of using temporary storage?
Yeah, so I guess a couple things. Prior to 7.4, we are probably too conservative with our temporary storage usage. And there were clients that we recommend, turn off this auto sizing and manually size the plan cache. And the way that, you would kind of indicate you had that issue was you see this property here that says the auto sizer wanted to increase the size of the plan cache, but it didn't feel there was enough temporary storage. So if you see that timestamp updating pretty frequently on your system, that's probably a case, assuming you feel like you have enough temporary storage, where you might want to manually size the plan cache. So that was the main reason prior to 7.4, we might suggest clients not use the auto sizer since 7.4. That's not something we think about much. Now, one benefit of increasing the size, assuming that you have your temporary storage, enough temporary storage to support it, is you're going to increase the chances of having a more historical record of the queries that are run on your system, right? Because then we're less likely to prune and remove plans that aren't used frequently from your plan cache because you've made the plan cache bigger. Now that does have a hidden temporary storage cost, and I did write about that in my blog. I don't remember the exact title, because not only does your plan cache take temporary storage, but sometimes when we run your query, and maybe let's say we did an in-memory sort to return your data by order date order, for example, we might choose to cache that sorted list for that query execution in memory in temporary storage. And on the next execution of your query, if the underlying data hasn't changed, we can just return the orders in order date order without having to resort the data. When you're manually sizing the plan cache, you are increasing the amount of, decreasing the amount of cache temporary objects that might improve performance that way. And my blog entry goes into more details on that, because then starting with the is it Power 11 hardware where we started doing compression on the processors. We actually do compress in there. If we were on a system with that level of hardware, there's a separate property here that says how many of the plans are compressed. So that kind of factors into that. So in general, unless IBM support has told you to manual size the plan cache because of some specific issue, I'm really a proponent. You should just use the default auto sizer.
I'm down to my last two questions, and then I'm going to refer everybody to the technology expert lab point. So I have two more questions, and I'll try to keep them short, please.
Okay.
All right. So the first one is for a consulting company trying to justify fewer IPLs. They have extremely high SQL activity on the server, and if the space used by temporary indexes is part of the size of the plan cache, or is that space somewhere else? If I read that correctly.
Yep.
My client system gets a lot of storage back with their weekly IPL, but it grows back to about the same size at the end of each week. I guess that kind of makes sense. They think it's the old temporary address cleanup problem. I'm looking for other evidence to help justify fewer IPLs.
Right. So that is a very good question. Current plan cache size, like we see here, is roughly 6 gigabytes. That's one storage container that comes out of the system ASP. But if we go down to temporary indexes, I think it's relatively small here. That is a separate storage container. That would be 11 megabytes. So they are all adding up, and that's what's disappearing at IPL. And if they're running the same queries that cause the same temporary indexes to be created after IPL, then I would expect by end of day Monday or Tuesday, this temporary storage usage has gone up. And then what I was talking about earlier is that sorted list and other temporary data structures that might get used as part of the query runtime. This is another temporary storage bucket that would grow after IPL and disappear at IPL, of how many of those internal temporary data structures have we cached to hopefully support future executions of a query running faster. So what I would do is I would get on the system right after an IPL and capture the fact that those two and the plan cache size are all relatively small, and what those values are, and then should be able to map it to how much the temporary storage looks like at the end of the week.
That makes perfect sense.
Yep.
Okay, and then the final one that I see here is if there is in fact an MTI, and then you do create the index,
yep,
the permanent one, do you need to change your SQL statements to now use that new permanent index, or is SQE sufficient, and is that going to see it and use it automatically?
It's going to see it and use it automatically, because when that query plan in the plan cache gets created, not only does it contain how we're going to run your query with the temporary index, it contains a list, and I don't think we really necessarily show it to you, of what permanent indexes existed when we built that plan. So when you create the permanent index and you run the query again, we're going to look at the query plan and say that permanent index wasn't there before. That might be a faster way to run the query, just like if they opened up a new highway to get to your destination, we'll automatically try to use that permanent index. And when we do, when all the users of that temporary index have run their queries, then that temporary index will disappear off the system at that point.
Without IPLing, just
without IPLing, without doing anything. You just have to run the application.
Brilliant. Kent, you've done it again. You've I've seen you speak at so many different events, and everybody is always, walks out so much smarter. And you've done once again. You've done that, and you're getting many rounds of applause on the screen. If you can see it or not, many people are clapping and sending thank yous. So this was
okay. Well, that's great to hear.
Absolutely,
Hopefully,
this was
get people pointed in the right direction of how they can, find slower running queries on their system and take some action on those.
This was very interesting, fascinating, interesting, all those things. And if this is new to anybody, I think this is a great way to get started. But you also mentioned other tools. You showed Visual Explain, and don't forget, of course, Index Advisor. That's another tool. I don't know if you actually showed that very screen on while you were talking, but that's another tool, part of your tool, your whole tool ensemble, isn't it?
Yep. All the great news is all of those are now linked to the SQL Performance Center. In the past, Index Advisor was kind of hidden, but if you have a recent version of ACS, now you can get at index advice data a lot easier and find your temporary indexes a lot easier.
Great. Really great. Well, I'd like to thank you, Kent. This was, people saying thank you, a lot of hands clapping, great detailed deep dive, very interesting. I can just read the chat, read them all day long here. There's so many.
Okay.
So thank you very much, Ken, for joining our little community here, the iChime community. You're now an official alumni.
All right.
So I want to thank you very much on behalf of everybody at the meeting. You kept our interest very high, and the attendance is just as high as it was when it started, which is amazing. That's great. So.
All right. Well, you're welcome.
Thank you.
Pleasure spending time with you all.
Thank you. For everybody else on here, anybody watching this video, I do encourage you, if you attend the conference, make sure if Kent is one of the presenters, make sure you check out his sessions. I promise you, you'll walk out with a wealth of information. He's one of the top Db2 for I consultants in the industry. So he's definitely worth somebody worth sharing some time with. All right, everybody. Thank you very much. Keep your eyes out, please, for the next round of invitations for next month's iChime meeting. And thank you. And we'll talk to everybody down the road. See you, everybody. Thank you.
All right. Bye.
Bye now.